All right, today we're going to start fluid mechanics. A fluid is any substance that can flow and assume the shape of the container. So that means both gases and liquids. Both gases and liquids. An important property that we'll be using a lot is density. So we'll be using density a lot, and that's defined as mass divided by volume. And maybe we'll do the gamma, which is rho g. So the weight divided by volume, okay? Okay. All right, another term that we should be familiar with is one called specific gravity.
Sorry, what's the rho?
Rho is the symbol for density.
And the other one?
What?
The other one, what is it?
The other one is gamma.
Okay.
It's just a weight density.
Okay.
Specific gravity, a substance's specific gravity is just the ratio of its density, the ratio of the density of the substance to the density of water. So something with the specific gravity of 0.80 would have a density of, would be 800 kilograms per meter cubed divided, and water is what? Do you guys know? You should probably know this. 1,000. 1,000 kilograms per meter cubed. Yes?
What's the row above the H2O sign?
Row of the substance?
Substance.
Yeah, because the definition, just the definition of specific gravity is the ratio of the substance's density to that of the density of water. Okay. All right. Shall we do example 12.1? Find the mass and weight of the air at 20 degrees in a living room with 4 meter times 5 meter floor and a ceiling 3 meters high. And the mass and weight of an equal volume of water. So, we're going to determine the weight, the mass, and the weight of air at room temperature that occupies a 4 meter by 5 meter by 1 meter space. That's 20 cubic meters, right? And air, you have a little table 12.1, gives you different densities of various materials. Air has a density of 1.20 kilograms per meter cubed. Okay, so then if I multiply that by how many, its volume, I'll get a mass, right? So that will be 20 meters cubed. Oh my gosh, I forgot my calculator. That's going to be what? Can somebody do that? 20.4 kilograms? Wait.
24.
24 kilograms?
Yeah.
So this is 24 kilograms? That's not very heavy, is it? Okay, and then that's the mass, and the weight is simply times 9.8. Which is about 240, 230 something, Omar?
I think I got my math.
235.2.
235.2 newtons. Okay, so that's the mass and the weight of air. Now, the problem asks us to find the mass and the weight of an equivalent volume of water. So all we have to do here is, I'm sorry, 22 meters cubed, I changed the wrong one. 1,000 kilograms per meter cubed. That's what, 22,000 kilograms?
Yes.
And then times 9.8, about 201,000 and something, 210.
21.
What is it?
215,600.
Newtons. Okay. All right. That is density. We'll be using that a lot. Okay. Pressure in a fluid. Pressure. Pressure is defined, well, first of all, its symbol is the capital P. It's defined as force divided by area. Its SI unit is the Pascal. We'll also be using a little bit of a PSI, which is pounds per inch squared. We might also use the pound per foot squared. When we study pressure, we use a lot of English units. A few things you should know is the atmosphere, ATM. And that is the weight of the column of air above us. And so at sea level, 1 atmosphere is 14.7 psi. So it's the weight of the column of air above us, the column of atmosphere on Earth, at sea level. Its value is 14.7 psi. Let's see. It is 1.013 times 10 to the 5th pascals. Pascals is a pretty small unit. You see that? 10 to the 5th and 14.7 psi. So pascals is like the penny of units. Okay, it's very small. Another thing that we need to be aware of is gauge pressure versus absolute. Okay, gauge pressure is, absolute is the entire pressure. Gauge pressure is absolute pressure minus the atmospheric pressure. So for example, if you have your tire, right? Oh my God. You know what happened? When it got cold last week, I don't know if you had this, I got a message on my car that my tires were low, right? Because the air contracts in the cold weather and the pressure goes down. So yeah, anyway, so I had to fill up the air.
Do you go to the gas station or do you go to the professionals?
I go to, no, I can do myself. How about you? You have to have someone to do it for you?
Not because you could yeah.
You have someone do it for you?
Yeah.
Yes.
You said gauge is absolute minus...
Minus atmosphere. So here's an example. So yeah, I go to the gas station and I run in and tell them to turn the air on. Then I come back and take the little tops off. And anyway, they have the tire pressure reader. It's some kind of piston, right? And it's got a little thing in here. Well, why does the tire stay inflated? Because the pressure inside is greater than the pressure outside. So when my car likes 35 psi, okay, but that's the gauge pressure, because I've got some air pushing the piston out, but I also have 14.7 psi pushing it back in from the atmosphere. So this is gauge, and that's atmosphere. So absolute, in other words, what the pressure would be if I took that tire out to space where I have no atmosphere pressing it, is going to be 49.7 psi. Okay? So we'll be doing some problems with gauge and with absolute. Let's see. The pressure in the bottom of a fluid is equal to the weight of the fluid on top of it. And that would be P equals rho GH. So that's the weight of the, let's say you want to get the pressure in a swimming pool. You take the density of water times G times the depth of the swimming pool. And that would be the gauge pressure. The absolute pressure is going to be P equals P naught atmosphere plus rho GH. Should we make these short so they're more?
Yeah.
Yeah, turn off now.